Hello, fourth graders. Happy Tuesday. I am here with your science lesson 30, and we are going to learn about lightning today. So continuing to learn about different forms of electricity. Yesterday we learned about static electricity, and today we're going to learn about electricity that happens in our atmosphere. So today is a little bit different. We have a reading that is already in your Google form. So just follow along with me and answer the questions using the video and the reading. So the first passage is called Flashy and Loud. A bolt of lightning is a huge electrical current. Electrical currents flow when positive electrical charges and negative electrical charges are drawn toward each other. During an electrical storm, clouds, air, and objects on the ground all become charged with electricity. The top of a storm cloud often acquires a positive charge. The bottom often becomes negatively charged. This causes particles in the surrounding air to become charged as well. Charged particles make excellent conductors of electricity between the sky and the earth. So, what they're saying is the top of the storm is typically positive, the bottom is negative. So, that storm is now charging other things in the sky. So things that are around the top are becoming positive. Things that are on the bottom are becoming negative. And we know when we have a positive and a negative, they're attracted to each other. So basically, this is causing like a circuit in the sky. Energy can go between the positive and the negative objects that are in the earth. So it's kind of becoming a conductor. It's making electricity easily flow through the atmosphere. So it says the stage is set for a cloud to ground lightning strike. When the difference between the positive charges on the ground and the negative charges in a cloud grows strong enough, lightning strikes. An electrical current flows through the charged air. So your questions for that passage: which types of charges come together to form electricity? So what's going on the top? What's going on the bottom? Are those the two positive charges? Are they two negative charges? Is it one positive and one negative? Or are they two neutral? Number 2, during an electrical storm, objects can become charged. True or false? 3, are charged objects conductors or insulators? All of those are in that short passage above. Please use it. All right, this passage is called Teaming Up. Lightning and thunder are a team. Lightning causes thunder. Thunder is the explosion that you hear when air is suddenly heated by lightning. The air can reach 50,000 degrees Fahrenheit. That's more than 5 times hotter than the sun's surface. This extreme heat causes molecules in the air to rapidly expand and vibrate. The vibrations create the boom of thunder. So our picture here, we've got a caption. It says, each year lightning strikes Earth about 20 million times. And this is an example of forked lightning. It says it gets its name from the way the bolt forks on its way down to the ground. All right, your questions on this passage: true or false? Thunder causes lightning to happen. 5, heat makes molecules in the air move quickly. What happens next? This one was really short, so go back to the passage, listen to me read it again, and find those answers. All right, last passage, we've got a map. So this map is showing us, let me zoom in. It's showing us how often lightning happens around the United States. So as you can see, the blue, this is 1 or fewer. So they're not getting much lightning at all. So over here on this side and up here, they're not getting much at all. 1 or fewer lightning flashes per year, per square mile. The light blue is 1 to 2. The yellow is 2 to 4. The orange is 4 to 8, and then the red is 8 or more. So most of the lightning happens down here in Florida, but really this whole area here gets a lot of lightning. The southern part of our country. Okay. Lightning and thunder occur at almost exactly the same time. Yet you see a flash of lightning before you hear the crack of thunder. Light travels nearly 1,000,000 times faster than sound. The sound of thunder travels 1 mile in 5 seconds. The next time you see a lightning flash, count the seconds until you hear thunder. Divide that number by 5, and that's how many miles you are away from the thunderstorm. So, neat little fact for you to try out next time we have a thunderstorm. Number 6 wants to know, according to that map, what part of the US has the most lightning flashes? And I gave you a compass so you can use the correct terms. So is that the north, the east, the west, or the south? There might be 2 correct answers, so use the compass. And same with number 7, which one has the least lightning flashes? Use the key, look for the lowest number. And the last question is, why do we see lightning before hearing thunder? I hope you guys have a wonderful Tuesday. Stay safe, ask for help. We are here for you, and we will see you tomorrow. Goodbye, Adams.